a wonderful program in its own right, will be helping us to inject those strings into the backend database to, extract data, wreak havoc, whatever else that we want to do with it. Now, I want to be sure I understand my audience that I have here today. So I would like to ask just very briefly, everyone who has actually successfully done an SQL injection, if you would kindly close your eyes for just a moment, do that. And then I'd like to know everyone who has not done an SQL injection, raise your hand, and you don't have to be worried about being embarrassed because all the other people have got their eyes closed. Excellent, that's what I needed to know. Okay, now you other people can open your eyes for the rest of the presentation here. That's good. Okay, now Sqlmap, I'm going to have to apologize. You people in the background are going to need better eyesight than you really think you do, but I'll try and slow down the presentation as much as possible to go over the parts that we need to. Is as you can see, a text-based tool here. It's written in Python, which is nice because it will run anywhere that Python will run. And we'll go ahead and we'll start out with some basic SQL injections using Sqlmap. I'm going to briefly talk about some of the extra options and advanced things you can do with Sqlmap, but we won't have time to get into that other than to just give you a taste and let you know that they are there. It's a very complex program, but it's also very simple to use. And then at the very end, we'll very briefly talk about how to mitigate against SQL injections, but since most of the people at this conference are just trying to do it rather than stop it, we won't spend too much time on that. Bear in mind, of course, that using this tool is illegal. This is the statute that applies here in the state of Kentucky. The chances of you getting caught are small, but if you do, I would suggest that you get a lawyer. That's all I'm going to say on that one. All right, so we're going to talk about how we can exploit a poorly protected SQL database, about as poorly protected as that bomb that just went off the end of the loading ramp there. And I'm going to show this with a demo program, demo framework called Sqlol, and you can Google that, find that, download that. If you're new to SQL injection, this is a really great little thing for learning how to do basic SQL injections. Now I modified it slightly for the purposes of this demonstration here, but it'll look a lot like this if you download the version that's out there. And it's got a series of built-in challenges. And if I can find my cursor, we're going to get over there and we're going to try challenge number 1. See if I can make that a little bit bigger for what's going on back there. What it allows us to do is it has a SQL statement behind this web page, and you type in your injection string and inject it, and it'll show you what the results of your attempted injection were. So what I'm going to do is I'm going to type something in here that is a recognizable string, and you'll see why you want to probably start with a recognizable string. I'm just going to put my name in there, which is Conrad, in case I didn't mention that. I work with NTT Data. And then we're going to go ahead and we're going to run the injection, and the demo part here will show you some extra stuff. The part we're interested in for the purposes of this demonstration is what we have down here. It'll actually show you the query string. It'll show you where your injection tried to go in and whether or not you got any results. Now in this case, simply putting my name in there didn't get us any results back. So my name is not a very good SQL injection. But if we look at, we go back up and we look at something that is too small for you to see, so you're just going to have to take my word for it on this demo. If we looked at what was up here in the address bar, we would see a series of get query parameters, so that we know that this particular call to the web backend is a get call, and it's passing in the parameters as query parameters. And we would see up there the recognizable string, my name Conrad, was set as the value of the parameter inject string. Now, what we can do is we can simply, Control C that address bar. Get back over here to the right place. And I couldn't see it either. So, much like the previous speaker, I'm going to have to back up here for a moment. Okay. And what we should be able to do, if I can find my cursor here, get this started up. All right, here we are invoking Sqlmap. Then we go and we just paste in the address bar that we copied out of the Firefox. You'll notice that here was this business where I said that the Conrad was the value of the variable inject string. Sorry, we see where Conrad was the value of the variable inject string. So we specify to Sqlmap that the parameter that we want it to try and use as its injection parameter is inject string. I also have to put in this disable coloring option because I found doing demos with Sqlmap before some projectors don't display the colors too well. And it'll go through, and sure enough, it has been able to discover that there are a couple of injection techniques that this particular web page is vulnerable to. One is called the error-based up here, and the other one is called the union query. Okay, well, now that Sqlmap has told us that this is vulnerable, we'll call our command back. And we'll tell it to show us what the various databases and tables are, and Sqlmap is able to figure that out. Our projector screen is cutting us off a little bit on the left and bottom, I'm afraid. But then once we've got the names of the tables and the databases from Sqlmap, we simply put that in there. We tell it to give us the passwords. We take a few defaults, and it will start a brute force dictionary password cracking. And if the logon ID, the SQL logon ID that is behind the web page has the access to do this, it'll go through, it'll crank up, it'll do the brute force, and you just have to sit there. I mean, this is the favorite part of my job. I just sit here and I just put my feet up, sip my coffee, and before you know it, it's managed to crack the password, give you the ID that was used, what the password was, and you just write that down, and you're done. So simple. Good old Sqlmap. it says next slide. There we go. I don't know why it's run so slowly here. All right. Now, the other thing that Sqlmap can be extremely useful in is blind SQL injection. And this is a case where your SQL statements that you submit through the web page don't actually return you any data. It simply, it's got some sort of indication. You know, you'll see that maybe you'll get a message, or it will take you to one page, or give you an option in one case or no option in the other, but you're not really getting anything from the back end. And because you can't really see any of the names of the the tables or the databases or any of that stuff that are in the back end in such an application, in order to do injection, we call that the blind SQL injection. Now, there is a requirement for this to be able to be done, is that Sqlmap has to have some sort of input that will reliably return a true condition, whatever that may be. You'll see that here in a minute. But there has to be something reliable. It just can't go off randomly. So let's go back to our Firefox. And what we're going to do in this case is find my cursor, and I'm going to crank up Fiddler here to capture the request. And that is because on this particular request we're going to be looking at, it is a post, not a get. So we're not going to be able to get it simply out of the address bar. So here's our handy proxy, which will capture what we're about to do. I'm just going to fire that up, get that out of the way. And then we'll go to the blind challenge. And I'm going to do the same thing I did before. I'm just going to put in my name, inject it, and we'll see what comes back is nothing. Well, that's not what's going to be considered a true result for Sqlmap. So that's not going to do us too much good at all. So we're going to go back. We're going to try something different. See, Sqlmap, I mean, it's not going to do all the work for you. I mean, you do have to do some of your own thinking occasionally. So another thing we're going to try here is we can come through and we can use the good old classic quote or 1 = 1 attempt to see if maybe that will resolve as a true condition to whatever this SQL statement is behind the scenes, the one that we can't see, the one that we're blind to. And in this particular case, well, we were lucky. It did result to a true condition because we see we now have a different message here. It didn't give us any data out of the database. So we can't really use this for data exfiltration yet, but it does give us what we need to be able to take the next step with Sqlmap. So now that we've captured that, we'll come over here. And you could do this with any other, Fiddler, Burp, Zap, the proxy of your choice. call it up. Need more caffeine on my computer this morning. Ah. Caught me unawares. Let's see if hopefully at least those of you in the front will be able to see this. All right, here's the post request that was submitted with the successful injection that we did to get the true statement back. And as with the others, we'll see that here is the inject string parameter, and then here's that tick or 1 = 1 business that we stuck in there. So what we would do is we would take this post request and that print's too small even for me to read. So we would do it as a save as, and we would save that as a file. And then once that was done, we could then come back to hello. Come back to Sqlmap. Start it up, sqlmap.py. Disable the coloring again so that at least you people in the front row can read it. This time, instead of pasting in the string from the browser address bar, we point it to that saved post request that we made. We noticed before we saved it that the parameter we wanted to fiddle with was inject string. I tell it to use the blind technique because we know that's the only one that's going to work. For the purposes of this demonstration, I specify that it's a MySQL database backend. If you didn't put that in, Sqlmap would eventually figure it out, but to speed things up a little bit, I just went ahead and put that in. Now, what happens here right off the bat is we get a warning here that Sqlmap says, it looks like you've got some what they call tainted parameter values. You've got some stuff in there that already looks like an injection attempt. And it says it's best if you don't stick that stuff in there before you give it to me. Now, we'll talk about how to get around this a little bit later, but for right now, for the purposes of this demo, that's okay. We can just leave that in. And we'll tell it, yeah, we want to go ahead and continue. Don't worry about that right now. And it goes through, and sure enough, it discovers how to do a blind technique. And you'll see what's going on here is it takes the part, the tick or 1 = 1 that we added in there that we knew was going to be true, and then it added its own little 6183 = 6183 and JBQP = JBQP stuff that it also knows to be true. And why it picks these crazy numbers, I really don't know. But it's enough for it to tell that when it puts those in there, it gets a true back, and if it puts like a 6183 = 6182, then it gets a false back, and it can tell the difference between the two. And that's how it knows that it's going to be able to do blind injection. So we crank it up, and we tell it to go ahead, and all right, now that you can do blind injection, go ahead and extract some stuff out of the database. We get the warning again. We tell it, don't worry about it. And it goes to work. And it managed to find these database values here. And we could tell it to pick a given database. Unfortunately, what you're not seeing here, because our display is cutting it off, what's happening is each of these values is coming back one character at a time. As you sit there, you would watch. You would see a B would show up. And then a moment later, a U would show up. Then a moment later, a Y would show up. And this is because it's not able to actually say, select, the tables out of the database, because it's blind. It doesn't have that ability. What it's doing is it's actually going in and it's saying, okay, check for the first letter in the name of the first table, and is it equal to A? And if it gets a true or a false, it says, okay, well, it's not. Then we're going to go to B. And that comes back, oh, okay, that is true. So that's a B. And then it goes on to the next letter. And so it laboriously goes through all the ASCII characters one at a time for each one of the names that you've asked it to come back to. And it does a pretty good job for this, and it's fairly quick. It's certainly a lot quicker than if you were going to try and do this manually sitting there, and you don't have to write your own scripts to go through it and all that kind of stuff. So we get the data back, and eventually get our table names there. And then we can pick, a particular table that we want, like that SSN table, and we can tell it, okay, just dump the values in that table, and it'll do the same thing. It'll go through each row in the table, and one character at a time, dink, 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 dink. Again, that's kind of the favorite part of my job, is just putting my feet up and watching this roll by on the screen. Now, if my boss happens to walk by and see this sort of stuff, then, I've got to call something else, start typing on the keyboard or something of that nature, make it look harder than it really is. But, that's really all there is to it. And so that's how Sqlmap can do the blind SQL injection. Really great, handy tool right there. Okay. Next slide, inline query vulnerability. Now, if the back-end database is vulnerable to inline queries, there are a couple of other interesting things that you can do, and Sqlmap will allow you to take advantage of those. So, going back once again here to our challenges. We're going to go to challenge number 10. And this is going to be kind of an interesting one. Because your classic SQL injection attempt is something where you're specifying some information over here in in the where clause, and you're trying to get that where clause to be like equals 1 equal 1, so everything gets dumped. But in this particular case, what's getting injected is actually the column name. And so what we see in our little demo program here is that what happened was, I stuck my name in here, select Conrad from the users table. Now the chances of that being the name of a column in the actual table are pretty small. So this could be, this could be a somewhat trickier thing to inject into. On my cursor again. But same thing we do here. It's a GET request. So we would come up here, copy that out of the address bar. Find my cursor. Run my movie. Sqlmap.py. Cut and paste in what we came out of the address bar, just like we did on the first one. Disable the coloring so that you can read it on the projection screen. You wouldn't need to do that on your monitor in your office. And it looks really pretty because everything comes up in different colors and stuff. Specify the injection string. Comes up here, finds out that test for inline queries, discovers that yes, indeed, it is vulnerable to inline query injection. And you can look at the kind of crazy payload that it sends in there when it is vulnerable to inline queries. Looks weird, but it works. So we just tell Sqlmap, okay, you got it. Go for it. Hit the button there. There we go. Boom, 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 boom. And it's able to go out there and extract the same SSN table that the blind one did. You'll notice that this one did it a lot faster because it was actually doing a select against the table instead of having to go through and do it one character at a time. The other thing that you can do, however, is, let's see, if you've got the inline query, there we are, is you can tell it to just go ahead and give me a SQL shell. Again, we're cut off a little bit here on the left, but you can see the shell and the fact that I was able to type in, select version, and it goes off, executes that statement, comes back with the information, and then I did a select star from the table. I just type that in, and it just returned that. So this is where the inline vulnerability can come in handy, because it'll give you the ability to just go and type in your own SQL commands. All right. So those are some of the basic handy SQL injections that Sqlmap can make it easier for you to do. Now, there are lots and lots of options available with Sqlmap. More stuff than you can shake a stick at. There's never been anything I needed to do that wasn't in Sqlmap. And this is just a few of them, but I want to point a few of these out because they think these will come handy as you start moving away from some of the most basic ones that you might be, some of those basic injections that you might be working with. First of all, one of the things you need to remember when you get started with Sqlmap is that as you enter in the Sqlmap commands and tell it to go do these things, it's going to be building on the results of the previous tests. Now, on one hand, this is a really handy thing to do, so that it doesn't have to go back and spend time, redetermining what vulnerability is there and how it's going to take advantage of it and that sort of thing, so it can speed things up as you go along. The drawback is, particularly if you're first getting started, if you get confused and you confuse Sqlmap and it starts getting confused, you're going to need a way to be able to tell it, whoa, okay, look, we just need to start over, fresh here. And so it has three options here that at different levels tell it to just, let's start over fresh. Which somebody told me is what that little pony is asking for also. There's also a handy option here called verbosity. Now, what you saw on my little movies there was the default verbosity, where it just comes back with the basic information messages, warning message if necessary, and will list, one of the final injection payloads that it came up with. As you specify higher levels of verbosity, you can tell it to show you all the payloads that it attempted to inject. You can take it farther than that. You can say, well, show me all of the complete HTTP requests that went through there. I mean, the whole get or post. Beyond that, you can also say, all right, in addition to that, give me all the response headers. And then finally, if you say, verbosity 6, it will give you all the response content coming back. Now, this can be particularly voluminous, especially in the case of the blind SQL injection attack, where it's going through and is having to check, every single ASCII character for every single position. You're going to get a lot of data back pretty quickly. But if you run into some problems or you don't really understanding what's going on behind the scenes, you can tell it to bring that back, and you can route it to a text file for other further analysis. So that can come in handy when you're getting started. Another thing to remember, if you need to have, for example, NTLM credentials just to get to the website, no problem. Sqlmap gives you an option to specify those before you take off. If someone happens to be watching what's going on, there are some applications or web inspectors that will kick you out if a certain number of consecutive invalid requests are noticed. And this is a particular risk with the noisier explorations like the blind one, where it's having to make lots and lots and lots and lots of requests. So there's a couple things here. Well, the simple one is the safe URL, and that will tell Sqlmap every so many requests, go to some place that is a good URL. So you can maybe fool that not so smart IDS into thinking that you're not really trying something bad. Beyond that, there is also a tamper option, and there are a number of pre-written tamper scripts that come with Sqlmap to help you get around most of the popular IDS packages that are out there, and then you can write, you can extend those and write your own. That's getting a little more into the advanced stuff. Don't forget this one. I forget it at least once a month. If the website that you are attempting to inject into is an HTTPS website, remember to use the option force SSL. Otherwise, what will happen is Sqlmap will simply come back and say that its request failed. It won't tell you that, hey, the reason they failed is because you forgot to specify SSL and it's an SSL site. And you'll just sit there for about 15 minutes not understanding why in the world this perf, because you typed it right into the browser and it worked. Why it's not working with Sqlmap? It worked yesterday. What's going on here? And you'll feel exactly like that. Insert your brain here. So when you get started, I can't emphasize this one enough. If you're going to write anything down from my talk today, write down -- force SSL. Remember that one. Now, how hard, how bad do you really want to get in? There are 5 levels that you can specify to Sqlmap, and basically what these tell it is how many techniques and attacks that it's going to try to get in before it gives up and says, look, I couldn't get in. I usually run at least 2. If you start getting around 4 and 5, it's going to, it could potentially take a long time to run. So that's kind of a trade-off there. The risk has to do with how likely the attacks might be to damage the back-end database. 1 and 2 are pretty safe. In my spare time. 3, if an appropriate vulnerability exists, could change the data in the back-end database. And if that's an issue with the particular testing that you're doing, you need to bear that in mind and stay away from that. If you're really, really lucky, there's even these OS command and OS shell that you can use with Sqlmap to be able to run the commands on the web server itself. The logon ID on the back side of the website, however, does have to have access to the web root directory in order for this to work. That doesn't happen very often, but if it does, you got it. It's right there in Sqlmap. Almost as lucky, and we saw this last time because it comes in handy for those databases that support stacked queries. You can use the SQL shell and then just get in there and just go crazy. For example, Microsoft SQL happens to be one of those backend databases that supports this stuff. All right. I do want to emphasize that Sqlmap is not always going to do all the work for you. Sometimes you do have to use your brain. And I'm going to go through a sample example of a vulnerability that I was able to use Sqlmap to help me crack. But not at first. At first, Sqlmap would not have known what to do with this sort of stuff. And then, in fact, I even ran an automated tool against this website, and it didn't detect an SQL injection vulnerability. But what it did notice was that in certain cases, it saw some error messages come back. And so that's when I went back and looked at this again, thinking that I might be able to turn this to my advantage. So the first thing I did was I put in a single tick mark, which you might be able to see right there. I tried injecting that one little single tick mark just to see what was going to happen. And sure enough, the website, very obligingly, replied with an error message, and it showed me part of what was clearly a long and complicated SQL query. And it said invalid syntax near tick, which was probably the one I put in, equals username, paren, union, select, and then you could see it went on and on. It cut me off here in the middle of the where, so I couldn't see everything that was there, but it gave me enough to give me some ideas of some things to try. So the first thing I did was, okay, I need to come up with a dummy SQL statement that's going to allow me to cut off all that stuff after the beginning of this SQL statement, the one I couldn't see anything of, but at least all that stuff I could see in the error message. So I tried the old, always start out with the good old A equals A or 1 equals 1, start with that to try and terminate it and put the semicolon in there. And then select X from Y where Z. I just thought, well, maybe it could take off from there. The reason I was not able to use the classic dash dash to comment out the rest of the SQL statement there was because I could see from the error message that the programmer had broken it up into multiple lines, and the dash dash will only comment out to the end of that particular line, and then the SQL parser will pick up the next one right off the bat on the next case. So I needed to come up with an SQL statement that would parse everything, not necessarily run it successfully, but at least parse it from that point on. So taking the error message, I kind of stuck that on the front of it and thought, well, let's see if that's going to work. And I get incorrect syntax near my semicolon. Well, I figured that was probably because I didn't have enough parentheses. So I stuck one in. All right, stick in a parenthesis. Let's see what happens. And it comes back and it says, okay, well, now your parentheses aren't lining up. All right, okay, so now I got too many right parentheses. I need a left parenthesis. So I stick a left parenthesis in. And I stuck it in over there. And once I did that, sure enough, I was able to get past the first SQL statement, which did something I really don't care what. At this point, I just need to be able to find an injection point into it. And the fact that the rest of the SQL statement didn't execute properly, it wasn't an issue. Just as long as it parsed so that the first one would actually run. And so now what I can do is take all this up here and I can specify that as my suffix parameter in my Sqlmap. And what it will do is it will append that to the injections that Sqlmap is going to be doing. So I now have a known good start that Sqlmap can then just start using its canned stuff in front of to start working toward. There's no way that, you know, Sqlmap would have been able to, you know, deduce this on its own. And I'll tell you, in real life, I didn't do this in 3 guesses. It took me a lot more than 3 guesses to come up with this, you know, when I actually did this. But once I had that, then I could specify it as the suffix parameter. I passed that on to Sqlmap and let it go, and it found injection vulnerabilities, and I was able to pull data out of the database all day long. Okay, to start wrapping up, why? Why do we still have SQL injection? I mean, I'll go back to work on Monday. There'll be a website waiting for me, and I guarantee you somewhere in there, there's going to be an SQL injection. And 5 years ago, somebody asked me about SQL injection, and I said, no, we have gone beyond SQL injection. You know, we have our frameworks, our developers are trained, you know, that's a vulnerability of the past. We need to move on to deciding, you know, how we're going to deal with, you know, man in the middle and cross-site request forgery and some of these more difficult things that are, you know, really get into the web stuff and not just this dumb old SQL injection stuff that should have been going away. But it still shows up. And I think one reason, I know for certain one reason I still see it is that these vendors bring in these applications, and vendors don't take this offense, you know, because I've been on that side of the table also, where they had what was a Windows Forms app at one point in time. They made a lot of money off of it. And now the client, of course, wants a web-based solution. And so they're just going to, you know, pick that up and in the cheapest way possible, translate things from, you know, the old Windows Forms-based over to a web-based application. And the cheapest way possible of doing that is going to leave you open to a lot of vulnerabilities, not the least of which is SQL injection. That's the best answer I can come up with. I really don't know why we still have this SQL injection in this day and age. But that being said, there are some potential mitigations for SQL injections. One of which, you know, it's the classic risk management. You either accept the risk, you mitigate the risk, you share the risk, or you avoid the risk. And there's a potential, I mean, you know, you could avoid the risk. Now, it sounds funny, but maybe, you know, the next time some vendor tries to bring in an application, you know, do some testing on it, and you find that it's rife with SQL injection problems, you just don't buy that one. You know, you just leave it alone. Or if somebody says, you know, we want to convert an old application over to a web, you know, tell people that, hey, you know, it's not that cheap. You've got to go back and do a lot of, you know, rewriting and redesigning you know, the architecture for it to work securely with the web. Whitelist. Always a great idea, particularly with SQL injection. Very handy. You know, check what's supposed to come in. Don't allow anything that isn't supposed to be there. Parameterization, again, helps. Not guaranteed. If somebody takes a bad SQL statement and, you know, just cut and paste it, it's still going to be a bad SQL statement. But you know, if they're writing it from scratch, parameterizing it will usually take care of the problem. Restrict permissions. Don't allow these back-end logon IDs like we saw on this particular web app to have the access to all these things that it doesn't need to. You know, make sure that those SQL logon IDs behind your web apps are using minimal permissions. And then, as we saw in the final one, you don't return any error messages. If that application hadn't returned error messages to it, I never would have guessed. 1,000 monkeys, typing on typewriters would never have come up with that SQL statement. But once I had those error messages, it only took one monkey about an hour, and I was in there. Okay, so enjoy injecting. Please use Sqlmap. It's a wonderful program out there and can make your life easier if you're in the business of showing how bad things can be. Thank you very much. You've been a wonderful audience. Enjoy DerbyCon.